New Orleans is a major American city that sits lower than the water around it. A place where land survives only as long as engineered systems continue to hold back what naturally wants to return. Unlike most cities, safety here is not provided by elevation or distance, but by levees, flood walls, canals, and pumps working together every single day. As long as those systems function, the city appears stable, normal, and dry, even though the surrounding water is already higher than the streets themselves. This dependence creates an illusion of safety, where risk does not disappear, but is simply stored behind walls, waiting for pressure to exceed design. In this city, failure does not arrive gradually. When systems give way, the consequences are immediate, physical, and irreversible. That makes the true story of this disaster different from what most people remember, because it does not begin with a storm, but with a design assumption. The assumption was simple and deeply trusted, that these barriers would always hold long enough, and that the city behind them would never have to face what failure would actually mean. Everything that followed began when that assumption was finally tested, as Hurricane Katrina pushed water, pressure, and limits beyond what New Orleans was built to withstand. The flood protection system of New Orleans was not built all at once, but layered over decades, expanding in pieces as the city grew and sank at the same time. Each section of levee and flood wall was designed for specific water levels and pressures, based on scenarios engineers believed were likely, not extreme. This meant the system worked well under normal stress, quietly holding back lakes, canals, and wetlands without drawing attention to itself. But the design depended on balance, because levees resist water best when pressure is expected, evenly distributed, and temporary. If water levels rose higher or pressure lasted longer than expected, the system had very little margin, leaving almost no buffer between stability and sudden failure. The system was not designed to fail safely, because collapse was treated as unlikely rather than something that needed to be planned for. Once the barriers were compromised, there were no natural routes for excess water to escape, leaving the city with nowhere for floodwater to go. This meant that when the system was finally tested by Hurricane Katrina, New Orleans faced not just flooding, but a design problem with no easy exit. In late August 2005, Hurricane Katrina approached the Gulf Coast as a powerful storm, carrying an immense volume of water toward a city already living below sea level. As Katrina moved closer, strong winds pushed water from the Gulf into Lake Pontchartrain and surrounding waterways, raising levels across the entire system at once. This surge did not target one location, but increased pressure everywhere simultaneously, loading levees and flood walls beyond what gradual changes would ever produce. Water levels continued rising for hours, turning a temporary storm surge into sustained force pressing against structures designed for brief events. At this stage, the system was no longer reacting to a passing storm, but absorbing sustained stress, with pressure building faster than the infrastructure was designed to release it. The first failures did not announce themselves dramatically, but began as structural weaknesses deep within levees and floodwalls under constant pressure. As pressure continued, those weaknesses expanded rapidly, allowing water to force its way through barriers that had held for decades. Once a breach formed, water flow accelerated, using the city's own canal network to move deeper and faster into low-lying neighborhoods. These failures did not occur at a single point, but at multiple locations, overwhelming any attempt to isolate or contain the flooding. By the time the storm began to weaken, the decisive damage had already been done, and water was moving freely into a city with no natural way to stop it. The first levee breaches did not happen in isolation. On August 29, 2005, multiple points across New Orleans began to fail almost independently under the same rising pressure. These failures unfolded rapidly, not over days, but within hours, as water forced open weaknesses that had never been meant to resist sustained load. Once a barrier gave way, water did not trickle in. It rushed, driven by height difference and pressure, turning containment systems into entry points. Canals that were designed to move water safely out of the city suddenly reversed their function, pulling floodwater inward and directing it straight into the lowest parts of New Orleans. As breaches multiplied, the system lost coherence. There was no longer a single line of defense, only fragments failing at different speeds. Water entered neighborhoods laterally, not from one direction, filling streets and homes far from the original points of collapse. Because the city sits lower than its surroundings, gravity now worked against it, pulling water inward and preventing any natural retreat. Each additional breach increased the rate of flooding, compounding damage faster than any response could realistically keep up with. There was no single moment when the city flooded. It happened in overlapping waves, spreading through infrastructure networks rather than across open ground. By the end of that day, New Orleans was no longer being defended from water. It was being filled by it from multiple directions at once. Once water crossed the levees, it entered areas of New Orleans that sit lower than sea level, where gravity no longer pushed floodwater away, but pulled it deeper into the city. From that moment on, flooding was no longer driven by the storm itself, but by elevation differences that trapped water where it arrived. Unlike rivers that eventually drain, this water had no natural downhill path, turning streets and neighborhoods into collection points. Pump stations were meant to remove rainwater slowly, not handle sudden volumes entering from multiple breaches at the same time. As power failed and capacity was overwhelmed, pump stations shut down one by one, removing the last active resistance and allowing floodwater to accumulate unchecked across the city. With no functioning pumps and no natural drainage, the water settled in place, rising slowly but steadily, turning hours into days of continuous inundation. What formed was not a passing flood, but a contained body of water held in place by the same levees that had failed to stop it. The city now functioned like a reservoir, where damage no longer came from impact or force, but from prolonged exposure to standing water. Materials weakened, foundations failed, and infrastructure deteriorated as floodwater remained in contact far longer than buildings were designed to endure. By the time the water finally stopped rising, New Orleans was no longer facing a temporary flood, but existing inside a basin that could not drain itself. As floodwater remained in place, homes began to fail not from impact, but from prolonged pressure acting on walls, floors, and foundations never meant to stay wet. Vehicles floated, collided, and finally settled where the water left them, collecting along streets and canals according to the slow movement of trapped currents. Road surfaces weakened as saturated ground lost strength, causing pavement to crack, sink, and separate under the weight of stagnant water. Electrical systems failed gradually as substations, cables, and underground connections were submerged beyond recovery. Below the surface, water infiltrated sewer lines and utility corridors, spreading damage through systems that were never designed to be underwater. With transportation, power, and drainage systems all compromised at once, New Orleans no longer functioned as a connected city, but as isolated pockets surrounded by water. The pattern of destruction followed the city's water network, not random chance, revealing how infrastructure guided both protection and failure. By this point, damage was no longer spreading outward. It was deepening as time itself became the most destructive force acting on the city. In the years that followed, Hurricane Katrina was often remembered as an unusually powerful storm, its wind and rain blamed for the destruction of New Orleans. But wind damage accounted for only a small fraction of what actually failed, leaving most of the city's destruction unexplained by the storm itself. The primary force was not the hurricane's intensity, but the volume of water that entered a city designed with no effective way to release it. By focusing on the storm, attention shifted away from the structural failures that allowed water to remain in place long after the winds had passed. This misunderstanding turned a systemic engineering collapse into a natural disaster narrative, masking how design limits shaped the outcome. As a result, Katrina became remembered for its force, rather than for revealing how fragile a city becomes when its systems fail all at once. New Orleans was not defeated by Hurricane Katrina itself, but by the reality that once water entered the city, the system protecting it could no longer function as intended. The disaster revealed a simple truth, that a city built below water level survives only as long as its engineered defenses remain intact. When the water had nowhere to go, the city stopped being land and became a basin shaped by its own design limits.